Yeah, what do you know about parallel and perpendicular lines? Could you draw an example here? Parallel lines are what? They run where they don't side by side. They don't touch or intersect. I guess you could say at all in the Cartesian coordinate system. Yeah, they run side by side, train tracks sort of idea. Perpendicular, on the other hand, what's true about them? You've got one line here, then perpendicular. Well, they're going to intersect, and they're going to intersect. You want to do that? Yeah, 90 degrees, 90-degree angle, right angles. Let's just do it up here. So the angles here, the lines here, yeah, they intersect, and if we square it off there, 90-degree angle, that means there. Yeah, those, that's what we mean by perpendicular. And of course, most of the lines are probably, well, I guess we graph two of them at a time, but if we have two lines, most of the time those lines are going to cross, but they're not going to be at a right angle, or they're not going to be parallel. So these are kind of special deals where they do happen to be either parallel or meeting up at 90-degree angles. So we were going to mention those here a little bit. Now, one thing we can observe here is that on parallel lines, what about the slopes? They're the same, yeah. On parallel lines, the slopes are equal. Because as we know, slope tells us about the slant and the steepness, and both of these are slanted the same thing, right? This one's going this way, and then this one's going the same. It's just over a little bit from it. So yeah, they have the same exact slope. And so from a standpoint of, if I have two lines, let's just put a couple here. So if I had y, say this one's, it looks like it could be something like y equals, let's make it 2x plus 3, just hypothetically. And then this one would be like y equals 2x minus 1, right? Couldn't it be? That would be believable on those. Y-intercept of 3, y-intercept of negative 1, and positive slope. So yeah, and so we can see there, if we have the y equals mx plus b lines, then yeah, obviously your slopes are going to have to be exactly the same. For parallel lines, this one's 2, this one has a slope of 2, right? These are the slopes. Both of those have a slope of 2. So those are parallel. Okay? Those would be parallel. Now, on the perpendicular side here, are these slopes the same? Not really at all. Let me do another set here. We can kind of, let me make it even more pronounced. Let's say this one is, it's about the same, isn't it? Make it even more. What I want to do here is make it really, really, all right, let's say that one's pretty flat there, and then this one has to come in pretty steep. That's what I'm trying to get at here. All right, so those two, another perpendicular set. All right, what I'm getting at here is, yeah, obviously these slopes are not equal by any means. And matter of fact, they're quite different because, for one thing, this one's going uphill, this one's downhill, aren't they? So that's one thing about perpendicular lines, is one has a positive slope, and then the other one has a negative slope. So they are perpendicular lines are always opposite in sign. So one's a positive, one's a negative slope. You can see that here as well. The other thing, though, that's why I kind of drew this one, is you can notice this is a little more pronounced. This one is not very big slope at all, whereas this one's pretty steep. The rise would be much bigger than the run. So this one would have, let's say this one is a slope, it's a positive slope, and if you rise one, boy, you're going to run way out there, aren't you, to that next. So the run would be something like, I don't know, 6. 6. Well, it turns out then this one, like we said, is a negative. And then the other thing is if you do your rise to run thing from here to here, well, you're going like down 6 and then over 1. Matter of fact, that's if it was 1/6, that's what you'd be doing. Okay? So here's the thing. It turns out that perpendicular lines are opposites, and then they're also what happens to the numbers here. They get flipped. So we say they're opposite reciprocals. The slopes of perpendicular lines are opposites, and they're reciprocals. So they're opposite in signs, and they're reciprocals. They're flip-flopped of one another. Okay? That's how perpendicular lines work. So if I had, say y equals 2/3 x minus 11, then if I wanted a slope, a line that's perpendicular to that, what would it be? Slope-wise, it'd be minus 3/2. So I could do a minus 3/2 x plus 5, whatever. It doesn't matter about the y-intercepts. But yeah, these lines here, they would be perpendicular. Because the slopes are opposite. One's positive, one's negative, and they're also reciprocals flipped over from one another. Okay? All right. Now, this will probably come up. So let's say we've got y equals, let's make it negative, let's do something we haven't done, negative 4x plus 10. What would be the slope of the line parallel to this particular? Parallel now. It'd be negative 4, okay? Exactly the same. Yeah, this is the slope of this line, so a line parallel would have exactly the same, wouldn't it? Negative 4, okay? What about the slope of a line perpendicular to that particular line? What would that slope be? It'd be a positive because it's negative 4, so it'd be a positive slope, and then flip that over, that's 4/1. So flip it over, it'd be 1/4. Okay? With me on that? Make okay sense there. All right. Okay. All right. Well, let's see. Let's do this. Okay. So we did that one. All right. Here's another one like that. Oh. Let me do this one first. Say we've got two lines, y equals 2x plus 1, y equals negative 2x minus 7. Are those either parallel or perpendicular? Well, are they parallel? No, obviously not, because this one has slope of 2. This one has a slope of negative 2, doesn't it? So for parallel, they have to be equal. What about perpendicular, though? Are they perpendicular? They're opposite, but what's wrong? Not reciprocal. Yeah, these are not perpendicular either. They're opposite, but they're not reciprocals. It has to be both to be perpendicular, okay? All right, so be on the lookout for that. They'll try to trip you up, maybe something like that. All right, now here's one other. Let's say we were wanting this one right here. We've got this right here, 4x plus 5y equals 9. What is the slope of the line parallel to the given line? 4x plus 5y equals 9 is our line, given line. What would be the slope of the line parallel to that particular line there? Is it 4? Is it 4? It's not 4, is it? Why not 4? Well, this is not the slope. Why not? It's not in y equals mx plus b form, right? So we've got to put this in y equals mx plus b form. And the way we would do that is get our little y by itself, right? Y equals mx plus b has the y on a side by itself, so I'm going to move the 4x, subtract 4x. Did this last time, I believe. And of course, this side, I choose to write it as minus 4x plus 9. Then divide by 5, both sides by 5, so that winds up being negative 4/5 x plus 9/5. Both that terms get divided by 5. So yeah, this slope is minus 4/5. So parallel slope would be same thing, right? Okay. All right. Now, we can take this also one step further here. Let's go ahead and do that. All right. So what would the equation of a line parallel to (4x plus 5y equals 9) be if it goes through the point 2, 7. So same line over there. I want to go parallel to that line, but I want it to go through 2, 7. Well, we've kind of already done a lot of the work. Because if I want it parallel to this line, what's the slope? Well, we've already said it would be negative 4/5. If we hadn't done all that, we'd have to go through that again, but we've already done it. This line has a slope of negative 4/5, right? By our work over here, we saw that. So a line parallel to it would have a slope of negative 4/5. Okay, but I want to take it one step further. What would the equation of that line be? Well, it'd be, I'd want a y equals mx plus b for my new line. I've got the m. M is negative 4/5. I just need to figure out b. How do I figure out b? One way to do it is to plug in the point. Yeah. Plug in the point. This is an x comma y, so I can plug in x to be 2, y to be 7. See, that would be, that's 2 over 1, so it would be negative 8 over 5. Multiply the tops, multiply the bottoms. And so then, just add the 8/5. So it would be 7 plus 8/5 is my b. However you want there, that's 7 plus, one way to look at it is 1 3/5 is 8/5, so that'd be 8 3/5 is b, which changed it to a mixed number. Let's change it back here to an improper fraction. 8 times 5 is 40, plus 3 gives me 43/5. b is 43/5. So the line parallel to it through that point would be y equals, it'd be negative 4/5 x plus b is 43/5. Okay? With me on that. All right? Okay. Well, let's do one more of those just kind of from scratch here. Find the equation of the line. Perpendicular to the same one. All right, 3x minus 2y equals 7. That goes through 3 negative 8. Equation of the line through perpendicular to 3x minus 2y equals 7. That goes through 3 negative 8. What is my first step here? Well, I need to figure out the slope of 3x minus 2y equals 7, don't I? Because I want a line perpendicular to it, and so a line perpendicular to it, I need to make it, the slopes as I need to make them, okay? All right, well, what's the slope of this line? It's not 3, right? I've got to do the y equals mx plus b. So get y equals mx plus b for this, like we did that other one. So how would I do that? Well, let's move the 3x, subtract the 3x. So I have minus 2y equals, and let's write that as minus 3x plus 7. And then divide off the negative 2. So that'll be y equals negative 3x divided by negative 2 plus 7 divided by negative 2. But all told, negative divided by negative is a positive 3 halves x, then positive divided by negative is negative. So the y equals mx plus b for this is this. So there's my slope of this line. What would be the slope perpendicular, though? Do the opposite reciprocal, right? It's a positive 3 halves, so it'll be a minus, and then reciprocal 2/3. Okay? So now the equation of this line, y equals mx plus b, well, I know the m. I just need to figure out the b. M is negative 2/3. To find the b, the way I do it anyway, plug in the x and the y. X is 3, y is negative 8. I chose very nicely here, didn't I? Yeah, the one way you can look at it, the 3's cancel there, so that's just negative 2, isn't it? Of course, negative 6 over 3, which is negative 2. Either way, I get negative 8 equals negative 2 plus b, add 2. So negative 6 is b. So I got it. The y equals mx plus b for this line would be y equals negative 2/3 x. b is minus 6, so it would be minus 6 then. So that line would be perpendicular to the line given and through 3 negative 8. Is that okay? I do that okay?